Okay, 383, polynomial functions. So, I think we talked about polynomials in the very first unit, the very first day. I think I remember saying this is the definition of a polynomial, but you're not used to seeing it like that. You're used to seeing this kind of stuff. All right. What do you call the numbers in front of the variables? Coefficients. I need the highlighter. Coefficients.
Would the 1 be a coefficient?
Yeah. Because I can write the last term as x to the 0, right? Okay, so the number in front of the term with the highest degree is called the leading well, that's not a highlighter. It's called the leading coefficient. So what's the we'll do it in a sec here. The term that has no variable, or is in this case x to the 0, is called the constant term. And the highest exponent is called the degree of the polynomial. So what's the degree of the one I just wrote? It's a second degree polynomial, otherwise known as a quadratic. Grade 11 math. That's basically all you do in grade 11 math. Okay, so here's our polynomial. X to the 4 plus 7x cubed minus 8x squared plus 5. What's the degree? 4. What's the sorry? Highest exponent. Boom. What's the leading coefficient? 1. It's the number in front of the term with the highest degree. And if there's no number written, it's 1. And what's the constant term? 5. All right. So I'm defining a polynomial functions. So polynomial functions cannot have negative or fractional exponents or powers. Okay, you're not allowed to have them. Or non-real numbers. What's a non-real number? When I say a non-real number, what am I talking about? Yeah, square root of a negative. So any negative or fractional exponents, so exponent of negative 1 or exponent of a half or a third or whatever, not polynomials. So all you have to tell me for these ones are if they are a polynomial or not. First one, Polly. Why not? There you go, right there. What about the second one?
No.
Nope. Because the negative exponent. What about C? It is a polynomial. Even though you have a square root of 17, it's not a negative number, and all the exponents are whole numbers, and none of them are negative. So yes, it is. What about D? No, because what does a square root mean if it's over the variable? Power of a half, right? So this means root 5 x to the 3/2 power. So nope. And E?
Oh, wait, no. I see.
E's trick. It's root 3 x squared to the power of a half. What's x squared to the power of a half? So it's just negative root 3x. So this is a poly. And F?
No. It's got a negative square root.
Yeah, you can't square root a negative number. That becomes imaginary or non-real. So, nope. Is that okay? All right, next page. So here we go. Tell me the first one, A. What's the degree of that polynomial? 3. Highest exponent. What's the leading coefficient? Always take the sign with it. So negative 25. Negative 25. What is the constant term? Okay. pretty straightforward when it's already all multiplied out. What if it's not? So we look at this one here, two binomials being multiplied together. You can multiply it out, but we're going to do it without multiplying it out, okay? So what is the degree of this polynomial? 2, because all that really matters is x times x, correct? So you're going to get an x squared, which is 2, which is also known as a quadratic. What is the leading coefficient? 10. All you have to do is multiply the 5 and the 2, because those are in front of the x's, so you'd get 10. And what is the constant term? -7, because you're going to multiply the -1 and the +7. And if you did multiply that out, you would get 10x squared plus 33x minus 7, and you can see all those numbers there. Okay, let's make it a little trickier. We're not going to multiply them out, but we're going to figure out the degree, the leading coefficient, and the constant term. So, what is the degree of this polynomial? 4, exactly, because it's the x to the power of 2 times this x squared. So it's x squared. Actually, I'll write it as x to the power of 2 times the other x squared, which is going to give you x to the 4. So the degree is 4. What is the leading coefficient? Close.
90?
Oh, wait. I missed that.
It's 90. So it's 2 times this 3 to the power of 2 times this 5. 3 squared is 9, times 5 is 45, times 2 is 90. Does everybody understand that? Without having to multiply it out. You could multiply it out, but that's going to be a lot of work, and I don't really want to do that. And what is the constant term? 2. So it's the 2 in front times this -1 squared times this 1 at the end, which is just multiply all the constant terms in the binomials, or that, well, and a trinomial, I guess. All right, B. Degree. Is the degree 4?
2.
It's 2 because of this addition, because it's like this x squared plus that x squared, which is just some term x squared. So the degree is 2. What's the leading coefficient?
6?
Nope. Hmm? 23, because you're going to go 2 times this number squared plus the 5, which will give you 23. And what's the constant term? 3. So 2 times -1 squared plus the 1, which is 3. And the reason, look, I'm like, nobody's really going to ever ask you this. What would happen is you're going to see later on, if you know the degree, and you already kind of know this, what does this graph look like? What shape is this graph? Sorry? Yeah, you can. It's a parabola because the degree is 2. It's a quadratic, right? And I know that this degree is 4, so I know what the shape of that graph is going to look like. And you're going to learn that this unit. And if the degree is 3, I know what the shape is. Okay, so that's why you want to be able to calculate the degree. And this number, the constant term, is really your y-intercept because it's when x is 0. If you put x is equal to 0 into here, that goes away, that goes away, that goes away. So it's 2 times negative 1 times that. So if I know that it's degree 4, I know the shape, I know the y-intercept, I can get a quick sketch of the graph. Okay, which is where we're going here. All right. Here's our polynomial function. P of x is equal to 0. Explain why the polynomial function has a degree of 0. Or P of x is equal to 7. Why does it have a degree of 0?
There's no exponent?
There is an exponent, but nobody ever writes it because you can write it like that, right? X to the 0 is 1. So it's because of that. That's why it has a degree of 0. Why is it called a constant function?
Because there's no before exponent?
There's no variable, so it can't change. What does that graph look like? Yeah, looks like that. That's all right. Are we okay? A little better than logs? 1 to 3, please. And I'd say you already know this stuff. You can classify polynomials by the number of terms. A monomial would be one term, so that's like 3x squared. A binomial, we've all seen those, like an x plus 2. Trinomial, that's the kind you always factor, this kind of stuff. It's got 3 terms. All right? You can classify a polynomial like that. You can classify it as a degree, which we also have done. A linear is degree 1, so that's your mx plus b stuff that you did in grade 10. Or everybody's favorite from grade 11, the quadratic. Okay. Or what we're going to start looking at is cubics, which is degree 3. Doesn't matter. Quartics, 5th degree. Quartics is 4 degrees. It's degree 4, 5th degree, 6th degree, blah, 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 blah. That's what we're going to start looking at today. Or not today, but this unit, how to graph them, how to factor them, all this kind of stuff. So, for example, it's a little easier if you have this visual here. So the first one is, what's the degree of this first polynomial in this table here? Nope. 0, right? Because it's like c times x to the 0. What does that graph look like? It's a horizontal line, right? Looks like that. It'd be and I guess I'll put c there. That's a c, if you can see that. The next one is what? What's the degree? 1. We would say that that is linear. What does a linear graph look like?
Does the view graph have a name?
You just say constant. I guess I could write constant. It's a linear line like that, right? Or it could be negative slope, but we've all seen those. What is the third one? What's the degree? 2. What do we call it?
Quadratic?
Yeah, quad. That's your grade 11 stuff. You know it's going to be a parabola up or down depending on what the a value is. And then the last 2 are the kind of stuff we're going to look at this unit, all right? So the next one is degree 3. We would say it's a cubic. Cubic graphs have generally that sort of shape, sort of a wavy thing, depending, it can go the other way too, depending on the a value, but we're going to look at all that later on. And a 4th degree polynomial, which you could call a quartic. Nobody ever does. People would just say it's a 4th degree polynomial. They have this type of shape. Or it could face down.
Oh, it's a W, okay.
It's a W, or it could be an M if it flips over. It could also be, like if you looked at the graph of y is equal to x to the 4, it looks like a parabola. The little bump in the middle has just been minimized to basically nothing. All right, we're going to get all into that. You don't have to know any of that stuff right now. The last two, we're going to get into those graphs later on. Okay, you can also call them based on their type of coefficients, so the numbers in front. If they're all whole numbers, all right, positive or negative, you'd say it's an integral coefficient. If it has fractions, you'd say it's a rational polynomial function. If you see the word rational, it means fraction. Okay, like the last unit, that very short unit that I was talking about at the beginning of class, called rational expressions, which means it's fractional functions. Rational functions, I guess I should have said. But that's down the road. And then this one is real polynomial, which means all the coefficients are real numbers, the kind that we deal with. They're non-imaginary. You can have imaginary ones, but for complex numbers, we're not dealing with that. Go to university, take higher level math if you want to start dealing with that kind of stuff. Square root of -1. So I could say, this is not in the course, but if I said square root -4, all right, you have to understand that the square root of -1 is equal to I. So what you do is you rewrite the -4 as the square root of 4 times -1, and this is not in the course, so don't write any of this down. Which then, because we're multiplying, I write that as root 4 times root -1. What's the square root of 4? 2. What's the square root of -1? I. So the answer is 2I. And then you can combine those things with the real number system to get what's called complex numbers. So then you'd write stuff like this. We're going way off topic here. 2I plus 1 is a complex number because it has real and imaginary mixed together.
I really love how like grade 9, they were like, oh no, they were like grade 6 teaching us algebra. They're like, oh, you can make the letters whatever you want them to be. Right?
No, you can't do that. Well, that's like science. In science, you're like, oh, this is why this happens. And then the further you go in science, you're like, that's all like the tiny stuff. And then there's all this other stuff are all the exceptions. Yeah. Yeah. I mean, they teach you the basics, but you're basically in the 1700s when you're doing high school science, right? We're way past that. Okay. All right. Let's just finish off this lesson. Here we go. Next page, page 386. All right. Are we ready for some algebra, people? Here we go. We have a polynomial function, -3x squared plus ax plus 8. We need to find the value of a. Now they give us some information. They say p of 1. Whatever's in the brackets goes where? In for x. So this is our x value. And what is this value? It's the y value, and you can think of the p of x as the y, right? People seem to like that a little better. How am I going to find a? Yeah, but what are you going to algebra?
You're going to stop P1 equals -9 into the equation?
You're going to put your x's and your y's into the equation and solve for a. So x goes in for all your x's. The -9 goes in for this thing. I get -9. Sorry? Okay. 1 squared plus a times 1 plus 8. And then you're going to, yes. Nope, because it's saying the polynomial function p of x is equal to blah. And I'm telling you p of 1, when I put x is equal to 1 in, I get -9. So now just algebra. What's -3 plus 8? 5, right? Did I do that right? -14? Did I do it right? Okay. So basically, if you have one equation with a couple pieces of information, one unknown, you plug it in, spits out the answer. All right? That's like grade, I don't know what grade that is. 6? It's a few lower grades. All right. Now, this is actually from Math 10, this bit here. Yeah?
What is -3 squared be 9?
It's not -3 squared. It's the 1 that's being squared.
Oh.
Because that's the x squared. All right. Now, we have another polynomial function with two unknowns, a and b. I don't know if anybody's ever told you this before. If you have two unknowns, how many equations do you need to make? How many equations do you need to solve for two unknowns? Two. If you have three unknowns, how many equations do you need to solve for three unknowns? Three. If you have 58,000 unknowns, how many equations do you need to solve for 58,000 unknowns? However many unknowns you have, that's how many equations you need to solve. If you don't have that, if I have two unknowns and only one equation, you cannot solve for the unknowns. Okay, they have to be the same. What? What about it? Same rule? Yeah. Okay, so we need to make two equations. We have two pieces of information. When x is equal to 2, we get negative 18. And when x is equal to 3, we get negative 13. What do you think we're going to do? We're going to make two equations by subbing in those values. So the first one, I'm going to go x is equal to 2, and I'm going to plug it in. So I get negative 18 plus b All right. I get negative 10 is equal to 2a plus b. Does everybody agree with that? Or are you just blindly copying what I'm writing? Are you blindly copying what I'm writing? Without thinking? Did I make a mistake? Basically, that's what I'm asking you.
I don't know. As soon as you asked me to think,
I did? Well, you can, and we will, but I don't know which variable to solve for yet. Because I have two unknowns, right? So I need, how many equations? Two. So I need to make another equation. How do I make the other equation? You sub in the other information. So I use this one now. Negative 18. Is that my other equation? Yep. Does everybody agree with that? Okay, I've got two unknowns, a and b. I have two equations. How do I solve? I don't know what that means. What do we do? Substitute what? You're right. But how am I going to do that?
You have to do it like make it a quadratic.
Uh,
And then you can like factor it out.
Okay, you're on the right track. You can't make it a quadratic because it's just degree 1. But you mean get everything to one side. So you're sort of on the right track. What you want to do is solve for a variable in one of those equations and then plug it into the other one.
What did you have the other variable mean?
You'll see in a sec. So which variable, we'll see the purple one. Which variable do you think is easier to solve for, 2 or b? Or sorry, did I say 2? A or b? Why is A easier? Why is B easier?
A is easier because both a, like 2a and the negative 10 can be divided by 2, so you can make it closer.
But then you have b over 2.
Oh.
But then you'd have b over 2. You generate a fraction. You can do it that way, but you're going to generate a fraction. If I just move the 2a over to the other side, what do I get? I just solve for b, right? If you have a variable with a coefficient of 1, that's what you want to solve for because it won't generate any fractions. If I solve for a, like Jackson said, you're going to go, no, I know. Or somebody said it. You would get this, and then you have to divide by 2. And you end up with that, right? I don't want b over 2, because then you're dealing with fractions. If you don't have to deal with fractions, I know everybody doesn't like fractions, don't deal with fractions. So we're going to then take, so I'm going to erase all that, because we're not going to do that. Now, what do I do with this?
Plug it in for B and A.
Exactly. That's what b is, so I put it right there. And then what have I done? Instead of writing b, I write negative 10 minus 2a. Now, how many variables are in that equation? 1. So we can solve for a now. Combine your like terms. Move the 10 over. A is negative 3.
Oh, the 10, yes.
All right, are we okay with that? Everybody's good with that?
Don't we have to find the B value?
Exactly. How am I going to find b?
Plug in the 3.
You can plug it into pretty much any equation you want. You can put it here, you can put it here, but it would make the most sense to put it there. And then you've solved everything. Let's do it in green. So then it just goes in there. Just watch your signs. So b is equal to negative 4. Is that okay? You want to see a super easy way to do it? It's so easy, we're going to do it in Rainbow. It's not easy, but it's simpler. I have 2 equations, these 2 right here. Okay, so I've got negative 10 is equal to 2a plus b, and I've got 5 is equal to negative 3a plus b. Okay? You would have done this in grade 10, but you probably don't remember it. You can add equations. You line them all up. Okay, I just took these 2 equations, and I lined them up. Okay, what it equals, the a's over top of the a's and the b's over top of the b's. I want to make the b's go away. What can I do? Subtract the equations. Negative 10 minus 5. What's negative 10 minus 5? 2 minus negative 3. 2 minus negative 3. Thank you. B minus B. No more B's. So what does A equal? Divide by 5. And then you can solve the other one just by plugging into one of those. Okay? It only works like this if you have the same coefficient here. But if you remember back to grade 10, you can generate the same coefficient by multiplying the whole equation by a number that would make it. But
And if the second one was negative B,
you just add them together, yeah. If the coefficients are the same, this is the faster way to do it. Okay? In grade 10, you learned how to do a whole bunch of different things, but yeah.
do you mean constant or is the B value a constant?
Sorry? Oh, it is the constant term. Are you talking about this thing here? It would be the constant term. You're right. 4 and 6, and then 9 to 12. 9 to 12 are just multiple choice. So it looks like it's more than it is. I'm going to give you till 10 after. I don't think you'll need that much time, but